Okay, so we have been discussing on the metabolism happening in the adipose tissue. So, what's the significance of adipose tissue? It's one of the major sites where the fat is stored in the form of TG, or excess of fat, or excess of glucose is converted into fat, and finally they are stored in the form of triacylglycerol. So, one of the major sites is adipose tissue. Other than adipose tissue, there is the liver, the various regions of the body. So, almost all the tissues are having the depot fat, right? So how is the TG synthesized? The synthesis of TG, of course, the metabolism happens through synthesis and also the catabolism. So what is happening in the adipose tissue, or what is the difference between the hepatic TG and the TG, or the fat adipose tissue, fat deposited in the adipose tissue? The fat deposited in the adipose tissue is responsible for carrying out what the TG synthesis, and this TG is used up for the energy production and all, right? This is happening. How is the TG synthesis happening? The TG triacylglycerol, as we all know that the triacylglycerol is made up of two raw materials. One is the carbon skeleton, right? And this carbon skeleton is provided by the glycerol molecule, and or glycerol 3 phosphate. It's actually the glycerol 3 phosphate, but in adipose tissue, glycerol 3 phosphate cannot be synthesized as such because it is lacking the enzyme glycerol kinase. Almost all the other remaining tissues are having glycerol kinase, and hence they can synthesize glycerol 3 phosphate from glycerol. Now, from where does the glycerol come? That we'll discuss in the catabolic phase. Okay, so there are two raw materials required. The two raw materials, one among them is the glycerol 3 phosphate, and the other is the three molecules of fatty acids, right? So, glycerol 3 phosphate is obtained as a result of phosphorylation of glycerol molecule. There are two methods with which the glycerol 3 phosphate can be obtained. In almost all the remaining tissues, the glycerol 3 phosphate are synthesized from the glycerol molecule by the enzyme glycerol kinase, right? And it is happening with the consumption of one molecule of ATP. And in case of adipose tissue, it is not possible because the tissue lacks the enzyme glycerol kinase. Hence, there is an alternative there. And what's the alternative? The glycerol 3 phosphate is derived from dihydroxyacetone phosphate. And as we all know that DHAP is an intermediate of glycolytic pathway. That is, glucose undergoes breakdown to give DHAP. This DHAP then undergoes a reduction, right, to give rise to what? Glycerol 3 phosphate, and the enzyme is known as glycerol 3 phosphate dehydrogenase. Okay, so it's a reversible reaction. That's why the name glycerol 3 phosphate dehydrogenase, right? So that's the basic difference between the TG synthesis in the adipose tissue and in the remaining tissues. In all the other remaining tissues, the glycerol 3 phosphate is synthesized from glycerol with the help of glycerol kinase, while the adipose tissue lacks that particular enzyme, and hence there, or in the adipose tissue, the glycerol 3 phosphate is synthesized by the enzyme glycerol 3 phosphate dehydrogenase. So that forms one of the raw material. And the other raw materials, of course, we know that it is a fatty acid. And how many number of fatty acids are required for the synthesis of triacylglycerol? As the name indicates, three molecules of fatty acids are required, and these three fatty acids comes only in a stepwise manner, not in a single step, right? So first, the glycerol 3 phosphate acyl transferase, or acyl transacylase, transfers one molecule of fatty acid onto the first position, converting glycerol 3 phosphate to 1-acyl glycerol 3 phosphate. In the subsequent step, what is happening? The second molecule of fatty acid comes, and there the enzyme is acylglycerol 3 phosphate acyl transferase. So this enzyme is one which fixes the second fatty acid onto the second position to the already formed acyl glycerol, 1-acyl glycerol 3 phosphate. Okay, and in the third step, what is happening? There's a in the third carbon atom, we know that there's already a phosphate group, so there is an additional step required. The phosphate group should be removed, and it's happening by the means of phosphatase enzyme. So the phosphatase enzyme removes this phosphate, right? And CH2OP will be replaced with CH2OH. Okay, then only the last addition will be happening, right? So water comes and inorganic phosphate is removed to give rise to 1,2-diacylglycerol. 1,2-diacylglycerol is then subjected for TG synthesis by diacylglycerol transferase enzyme. So this is how the TG is synthesized in the tissues, in the adipose tissue, right? So in the adipose tissue and in almost all the other tissues except intestine, intestine, right? The TG synthesis is happening in this way. But in the intestine, we know that it is a site where the digestion and absorption happens. So from the dietary sources also we can obtain TG. But what is happening? Due to the digestive enzymes, the TG undergoes partial breakdown. And in the intestine also, the TG synthesis can be happening in a repeated manner. That is, the dietary sources provides the TG, and in the various stages of intestinal mucosa cells, the TG will be undergoing partial breakdown to give DAG and 2-MAG. Now, it absorbs, it undergoes absorption into the in the intestinal lumen, where what happens, the TG resynthesis happens. So digestion, can you, what is digestion? It is a breakdown. So after the breakdown in the intestinal lumen itself, what is happening? The resynthesis of TG happens. But then the difference is that it is only the 2-MAG that is involved in the synthesis. So it is happening, it is not the synthesis, it is a resynthesis of triacylglycerol which is happening. That's only a modification is happening. The partially digested lipids is again re-entering back into the TG synthesis. So there, or in the intestinal lumen, the synthesis of TG is rather simple because we are already having a partially synthesized product. So from this partially synthesized product, we are completely synthesizing the triacylglycerol. So 2-MAG will be there. So 2-MAG will be converted into 1,2-DAG. 1,2-DAG will be again undergoing one more addition of fatty acyl group to give triacylglycerol. Okay, so this is how the synthesis happens. Now next we are entering into catabolism of TG. So what is the purpose of catabolism of TG? Why is lipolysis happening? Why are we storing TG? We synthesizes and stores fat for the energy purposes, right? Because when compared to all the other biomolecules, lipids are the preferable source for energy, because we know that they can synthesize large amounts of ATP when compared to that of equal quantities of glycogen or proteins. So they are immediate source of energy. അതുകൊണ്ട് തന്നെ the fats is never wasted out from the body, and they are stored in the form of depot fat. So it in a daily basis itself, there's a repeated turnover. That is, എപ്പോഴും adipose tissue, it's not simply stored there. They are always undergoing utilization. എപ്പോഴും അവരിങ്ങനെ mobilize ചെയ്തുകൊണ്ടേയിരിക്കും. That is, they are in a state of motion. Okay, so the TG will be utilized continuously in the body. They are not remaining idle. They are always used up. So how are they used up? Nothing. The TG enters into the phase of catabolism. So only during the catabolism the energy can be synthesized, and this phenomenon is known as lipolysis. So what are the products of lipolysis? Of course, glycerol and fatty acids, because the synthetic products are they are synthesized from glycerol and fatty acids. So on breakdown also they give the same products, that is glycerol and fatty acids. And എങ്ങനെയാണോ അവർ synthesize ചെയ്തത് അതേപോലെ തന്നെയായിരിക്കും അവർ breakdown ചെയ്യുക. We know that the fatty acids were added up only in a stepwise manner. In the degradation also, the fatty acids will be removed in a stepwise manner. They will be removed in one by one. So the degradation, the enzymes involved in the degradation are known as lipases. Okay, so TG is acted upon by lipase enzyme. So one molecule of water comes and it acts on the first carbon atom, right, on the, or the fatty acyl group present on the first carbon atom of the glycerol skeleton, to give rise to 1,2-DAG, 1,2-diacylglycerol. 1,2-DAG is again undergoes lipase enzyme by water molecule, and the second fatty acid is also removed to give rise to monoacylglycerol, and the monoacylglycerol is acted upon by MAG lipase to give rise to glycerol. Okay, so this is how glycerol is formed. നേരത്തെ ഞാൻ പറഞ്ഞു സിന്തസിസിൽ ഗ്ലിസറോൾ എങ്ങനെയാ വരുന്നത് എന്നുള്ളത് I'll be explaining in the catabolic phase. So this is how glycerol is formed in the body, right? So in all the tissues, glycerol can be converted into glycerol 3-phosphate except adipose tissue. Clear? So the TG upon breakdown gives rise to glycerol and fatty acids. So this glycerol itself cannot be can be carried out for utilizing or synthesizing the TG. It has to be first activated, and this activation is carried out by glycerol kinase enzyme in case of all the tissues except adipose tissue. In the adipose tissue, what is happening? This glycerol cannot be utilized. So glycerol, it's not utilized. In the adipose tissue, what is the source of glycerol 3-phosphate? It is the glycolytic intermediate dihydroxyacetone phosphate. Right? Now, regarding the lipases, there are two types of lipases. Hormone sensitive lipase and lipoprotein lipase. So it is a hormone sensitive lipase that is present in the tissues, which is responsible for carrying on the TG breakdown, while lipoprotein lipases are present in the plasma. So what's the basic difference? We know that after digestion, for example, in case of exogenous TG, if the TG is derived from the dietary sources, what is happening? The dietary sources releases the fats. Lipase enzyme, lipoprotein, lipase enzyme comes in the diet. We'll be having triacylglycerol. So the various stages of or various areas of the digestive system, lipases comes and breaks down the TG into 1,2-DAG, 2-MAG, etc. by lipase enzyme, right? And they are under the control of hormones. So they are known as hormone sensitive lipases. And after digestion, what is happening? After digestion, absorption will be taking place. And during the absorption, we know that in the intestinal lumen, what is happening? The TG resynthesis is happening. That is 2-MAG will be converted into 1,2-DAG first, followed by triacylglycerol. Okay. So the resynthesis of TG happens in the intestinal lumen. Now what happens to this TG then? The TG has to be taken into the liver for the further metabolism. So how are they taken into the liver? If they are taken into the liver by a lipoprotein known as chylomicrons. Why they seeks the help of chylomicrons? Because we know that lipids are fat soluble in nature. They are not soluble in aqueous medium. And again, blood is aqueous in nature. So how can these fats coming through the dietary sources be transported to the liver? It's only with the help of protein molecules, right? So only with the help of proteins, the fats in the intestine can be taken into the liver. And those proteins which are responsible for transporting fats after digestion and absorption in the intestine into the liver are known as lipoproteins. So that's a function of lipoproteins. Lipoproteins are responsible for carrying or transporting the lipid molecules from one side to another, from the intestine to the liver, or from the exogenous source, from the dietary sources. The fats derived from the dietary sources are taken from the intestine into the liver with the help of a class of lipoproteins known as chylomicrons. I think you might have studied in the first year what are the different types of lipids, what are the different types of lipoproteins, etc. There you had an introduction on the chapter of lipids. So there you might have heard about this term lipoproteins. So what are lipoproteins? Lipoproteins are a class of molecules. They are protein molecules which can take or transport the water insoluble lipids from one tissue to another tissue. And there are different types of chylomicrons based on the density difference. When a blood sample or a serum sample or a plasma sample is centrifuged, is subjected for ultracentrifugation, you can see that the lipids will be getting sedimented in the form of various layers. And these layers are made up of these lipoproteins. So based on the difference in the density gradient, there are different classes. And the least dense molecules are the chylomicrons. That is, they are rich in lipids. Chylomicrons. Then it is followed by VLDL. Then there is a IDL. Then there is a LDL. Right? Then comes the HDL. So VLDL, LDL, IDL, HDL. VLDL, very low density lipoproteins, then intermediate dense lipoproteins, then low density lipoproteins, high density lipoproteins, and free fatty acids. So these free fatty acids are in fact not included in the group of lipoproteins because they are free fatty acids. They are not having any protein part. That's why they are known as free fatty acids. Right? So free fatty acids are not in fact lipoproteins. But when you are centrifuging, you get a separate layer of free fatty acid. Right? So this is how the lipoproteins are classified. And each lipoprotein has got separate function or unique function to carry out. The function of chylomicrons is to transport the dietary lipids or dietary TG from the intestine to the liver. It is the chylomicrons that transport the lipids from intestine to the liver, while VLDL transports the endogenous lipids from the other tissues to the